Hello viewers, welcome to NRI CSM. This is Vijayalakshmi from NRIIT. Let us discuss about the supervised models in machine learning. First we discuss about the what is supervised learning and supervised learning models like KNN, linear regression and Navi-Bayes. Firstly, what is supervised learning? Supervised learning is the subcategory of machine learning. While training the supervised learning, it uses the labeled data and the model learns from the training data and predicts the output on unseen data. There are two types of supervised learnings. One is regression and second one is classification. The regression outcome is continuous and the classification outcome is category. The example of regression is salary, price and age, etc. And the examples of classification are true or false, male or female, etc. Next, as we discussed before, in this model, it is trained by the labeled data. When we test the model on the same data without any label, it predicts the output. Here we gave the labeled vegetables like tomato, carrot, bell pepper are given to the model and it is trained by extracting the features of the vegetables and predicts the desired output. Next, coming to the k-nearest neighbors. The k-nearest neighbors used for the both classification and regression. Here k is the positive constant and it is defined by the user. Based on the k value, the nearest points are selected. While in training phase, the features and classes are stored. While in testing phase, the distance from the every point to the test point is calculated and based on the k value, it selects the nearest points. Next, here yellow point is the test point. We have to find the yellow point belongs to which category. For suppose, take k is equals to 5. On selecting the nearest points to the yellow point, the majority is more to blue points. Hence, it belongs to the positive reviews. Next, coming to the linear regression. Linear regression is primarily used for the regression problems. It is used to make the prediction continues depend on the variables. When it is straight line, it is linear and otherwise not. Formula for the linear regression. Y is equals to mx plus b. Here y and x are the variables. M is the slope and y and b is the y-intercept of the line. Next, here we have to change the line of regression until more data points are covered. Next, taking x and y values are given here and we have to obtain the xy and x square, y square and sigma x, sigma y, sigma xy, sigma x square, y square. For calculating the b0 and b1, there are formulas. b0 equal to sigma y into sigma x square minus sigma x into sigma xy divided by n into sigma x square minus sigma x square. On calculating that b0 is equals to 0.1514. Like same, the b1 also calculated. Here the straight line is y is equals to b0 plus b1x. On substituting the b0 and b1 values, here we getting the final straight line. Next, coming to the Navi-Bayes. Navi-Bayes is a classification technique that is used for the classification problems. Next, here Navi means the assumption and Bayes is the Bayes theorem. The classification is done by the probability of the Bayes theorem. The formula for the Bayes theorem is probability of A by B is equals to probability of B by A into probability of A divided by probability of B. There are three types of weathers: overcast, sunny, rainy, and we have to find the probability of play based on the weather. First, we have to find the frequency table which takes occurrence of the weathers for S and no. Next, we have to find the probability of overcast, sunny, rainy for both S and no. And next we have to calculate the probability of S and no. Next we have to find the both S and no probabilities for each weather among the total. Here the probability for S with overcast is more. Hence we can play in the weather of overcast. Thank you for watching.